Hello, my name is Liam Donahue. I am a freshman mechanical engineer, and this is my final project for Dr. Young's ENES102, a structural analysis of the rigging of the Hobie Getaway. The Hobie Getaway is a type of sailboat produced by the Hobie Company. The reason why I chose this project and the reason why I find it interesting is because it's what I learned how to sail on as a kid at a local summer camp in Poolsville. And I've always been curious to find out how much tension is in each cable and the overall safety of the system. Now that I've learned more concepts from ENES102, that would be articulated as a safety factor. The rigging itself is not the entire ship. It's actually consists of the mast, in addition to the stays that hold it up and any weight that the mast might be holding. The mast is mounted to the boat using a ball and socket joint, which allows it to stay in place while allowing it to freely rotate. It is secured for both rotation and for a bit of X, Y, and Z forces by that ball and socket and by the stays, which again keep it secure through moments, which makes it very useful for a moment analysis. In addition to a 3D particle and rigid body equilibrium analysis, as it exists in 3D space and is fairly symmetrical. The forestay, which is the one in the front, connects to two smaller cables or bridle, which connect directly to the hulls. They are these stays, as they're called, as they make the mast stay, are simply made out of stainless steel cable. I have some specifics later. Or I have some specifics here, rather, specifically 1x19 strand wire rope. Since I was not able to find enough details concerning the cross-sectional area of the mast or the cross-sectional area of the pins or the weight and weight distribution of the sails, I'll not be including those in my analysis. I would have liked to, but again, I could not find the details concerning that. So I will be judging the safety factor and the stress and strain purely of the cables. And through use of those material properties, I'll be able to determine how safe the system is. Like I mentioned earlier, I'm going to be looking at all of the weights involved in the system, which includes the halyards, which are the ropes used for hoisting the sails, which lie right on the starboard or right side of the mast. Using this diagram and a XYZ axis with X running positive X towards the bow, positive Y into the page, or towards the port side, and positive Z directly upwards, and the origin set at the base of the mast, I was able to calculate these points, represent them using my, albeit limited artistic skill, create these position vectors, find these force vectors, including the tension forces and the weights, and then I apply that to moments. So taking the moment about the origin, considering the mast and the tension forces acting on the mast, I was easily able to find the tensions in both the side stays and the forestay. Then after that, I did a bit of 3D body equilibrium analysis in order to find the tension in the bridle stay components, which was about 27.7 pounds. After doing that, I found the stress in each cable, which is simply internal force, or tension in this case, divided by area, cross-sectional area. They're all made of the same 5x16 inch cable, so therefore they each have that area as listed on screen. I found that the largest stress experienced by the cable is 361 psi, and that is in either the cable EC or cable ED in the bridle. Since these cables have an ultimate strength of 16.3 times 10 to the 4th psi, all we need to do is divide the ultimate strength by the largest observed stress, and we can find that the system has an overall safety factor of 451. Finally, simple sum of the forces in X, sum of the forces Y, and sum of the forces in Z, in order to find the reaction forces due to the ball and socket. These are the final forces that I had in my findings. Everything that I set out to find in addition to safety factor. It should be noted that the safety factor is likely greater than reality, as I was not able to account for all of the pins in the system. However, I've never once seen the system fail when used, maintained well, and when operated correctly. So I would not be surprised if it does have a significantly high safety factor. Overall, I really did enjoy this project. If you would like to read more about what surprised me and some of my thought process, feel free to pause during any of these slides, especially particularly these last ones. I really enjoyed this project as it allowed me to apply my engineering know-how from ENES102 to a real-world system that I'm actually somewhat familiar with already. And helped me understand something that I was always curious about. If you would like to read more about the Hobie cat or any of its dimensions, here's where I got that information. With all that out of the way, I would hope you have a very nice day. Thank you for enjoying my presentation.